All right, so substitution. Substitution stands for replace. So when you're looking to set up a problem for substitution, you're going to want one of your equations solved out for a variable. So each of these is set up for substitution. So if you have that, use substitution. If you don't, I'll show you elimination. That's going to be the method to go. But if you have an equation set up like y equals x plus 1, that's a great thing to have because now you know y and x plus 1 are the same thing. So anytime you have y, you can replace it with x plus 1. So here's what you'll see happening. You're going to take x plus 1, you're going to substitute, like replace. So same as like when you're substituting for somebody in sports, or a substitute comes in and teaches for a teacher, that's going to be what we're doing. We're replacing something with the equivalent expression. So what happens is then you're going to have that x plus 1 is going to go in for that y. So your 2x, now the y is going to come out, and I'm just going to show with red here. That becomes x plus 1. And then the rest of our equation is just equals 7. So that 2x plus y now becomes 2x plus x plus 1. I'm taking my expression, putting it in for y right there. Then we're down to this. Can you guys handle that algebra? What's the first thing you would do? Yeah, let's get the like terms together. So I have a 2x and an x, which makes 3x. Then at the same time, I can think I'm going to have to subtract that 1 over. So we get 3x equals 6, x equals 2. One of the common mistakes I see is we stop right here. This is half of our solution. So you think back to when we graphed these, found where that intersection is. How many coordinates are on a graph? 2. We have an x coordinate and then a y coordinate. So we're going to take now that x coordinate, we're going to substitute it back in. This top equation would be pretty easy. So put 2 back into here. 2 plus 1 is 3. So we also know that y is equal to 3. Our answer we'll write as an ordered pair. It will be 2, 3. X coordinate first, y coordinate second. So if we see one of our equations solved out for a single variable, we're going to use substitution. It's a very easy method. We can get those going pretty quickly. So each of these is set up for substitution. This one will replace x with y minus 2. And you're going to have to do a little distributive properties. So if we have 3 and x next to each other, we'll put that in parentheses, distribute it out. And same thing here. We have a y is 2x plus 3. We'll substitute that in for y. Again, put that in parentheses because you're subtracting 2x and you're subtracting 3. So it's going to be like a -1 that will distribute out when you're doing that third one. So that's how we can use substitution. All 3 of those are set up pretty nice for that. Is that okay if I delete this one? All right, we'll take a look then at elimination. So elimination is kind of cool because you can actually add or subtract your equations because they are working in the same system. They're working together. So you can make equivalent equations by adding or subtracting your 2 equations together. So why would we want to use elimination? Well, each of these, we do not have a variable solved out, so where we can get a nice substitution. So we're going to move to a different method. We're going to move to this elimination. So solving by elimination, you can add or subtract your 2 equations together to try to eliminate a variable. I'm going to do 2 of these because we're going to look at a couple of different scenarios. We'll do this one, and then we'll do 9. We'll do these 2. So I'm looking to add or subtract to try to eliminate a variable. One thing really nice about this one is I have a plus y and a minus y. You think about if you add a positive version of a number and a negative version of a number of the exact same number, what are those always going to add up to? Like a positive version of a number and a negative version of the same number. What's it always going to add to? 0, additive inverse. So whenever you add 2 numbers, and when you add 2 opposites, they're always going to add up to 0. So eliminate means exactly what it is. We want to try to get rid of a variable, so that's what we can do with this first one. We can take and we can add our 2 equations together. This is going to become 2x. y plus negative y is going to cancel out. This is going to become 12. So I've made a third equivalent equation, but then look at that third equation, how many variables are there? We're down to 1. Can we solve that for x? Easily. Put that in, x equals 6. Now you're going to do a little substitution. So I guess, yes, we are using a little substitution as well. Just think of 6 up here. 6 plus what number is going to equal 10? 4. 4. So y is going to be 4. So there they are. Write your answers in ordered pairs. 6, 4. There would be our result. My preference is to use adding every time. So like this one, I would add, the x's would cancel out. So we'd get an equation that solves for y. You could also subtract. So like this one, you could do x minus x, which would cancel out your x's. And then you'd have to do y minus 3 to get your y's organized. You could also just change each of these numbers to their opposites. So then you could add and cancel out that x. It's kind of up to you. I like to look at everything like adding, so it makes it a little easier, but you can do however preference you want. Let's take a look at 9 then. So 9, I got a positive x, positive 3x. If I add those, it's not going to cancel out the x's. I got a positive 2, negative y. 2 plus negative 1 is still 1y. It's not going to cancel the y's. But another thing that you can do is you can multiply your whole equation by a common number, and it's still going to be equivalent because they'll still be in the same ratio. So I'm thinking to myself, if I got a plus 2y, what could I add plus 2y with to make it cancel, to make it 0? Well, that would have to be a negative 2y. So that second equation, I'm going to multiply everything by 2. So I'm not going to use this one anymore. I'm going to make it 6x minus 2y equals 18. So as long as I multiply each term by 2, it's still going to be in the same ratio as that original equation, so it's still equivalent. But what I did now is I've made a positive 2y and a negative 2y, which are going to cancel. So a little bit more work to do. We got x plus 6x is 7x. 2y plus negative 2y is going to be 0. 10 plus 18 is going to be 28. So there's yet another equivalent equation. Just adding the two equations together, since they're working together, we can add them together, and now we've got a single variable. Solve that out, we get x equals 4. There's half of our solution. This top equation looks pretty good. I'm going to kind of erase what I put there because it's kind of covering up a little bit. You put a 4 into here. 4 plus 2 times something equals 10. Well, 4 plus what number equals 10? 4 and 6. So this has to be 6. 2 times something needs to equal 6 right here. What does y have to be? 3. So y would be 3. Y equals 3, which is going to give us a solution of 4, 3. So there would be our elimination happening again. So I'm just going to cheat ahead and look at this one. I like this, 5 and 10. This is negative, this is positive, so I can get those negatives, positives cancel out. If you multiply this top by 2, that's going to make that negative 10y. Then your 10y's are going to cancel, and you're down to x's, and you're ready to go. So elimination is really nice when you've got neither equation is solved out for a variable, and then you're just attacking it, going to solve for x and y. We're going to continue to practice all these methods because it is a skill to have kind of a recognition of when to use substitution, when to use elimination, when to use your calculator, because they all have pros and cons. And we're going to kind of look at when is the right time to use each of those. Okay? If you have any further questions on 3, 2, let me know. I just kind of barely scratched the surface on those, so we'll continue to discuss that if you need to. The only other thing then is was talking about the calculator. Just a couple of real quick things.